Hello all, welcome to Embedded Linux Learning Point, a learning platform for anyone who wants to learn Embedded Linux and Internet of Things. In this series of videos, we are building an IoT platform called Sense and Act. In this video, we are going to look at how to choose the hardware for the main board. In order to choose any hardware for the main board, so we have defined a certain criteria. So these are the criteria that are used for selecting the hardware. The first criteria is it should be an open source board and has a very good community support, because in case we want to build our own hardware, so we should be able to do that. The second criteria is it should be able to run embedded Linux. So one of the main reasons for this project is also to learn more about embedded Linux and embedded Linux development. So the board must run embedded Linux. The third criteria is it should have support for more connections like GPIOs, CAN bus, I2C, SPI, or serial ports. It should support PWM and the analog inputs. So these are some of the peripherals that we are looking for, because since it's going to be an IoT platform where we want to interface sensors, so we obviously need analog inputs, and to control any devices or to control any actuators, we would need GPIOs and any other bus system. So that is the one other criteria that we are looking for in the board that we're going to choose. So after doing a bit of research, so I boiled down to two boards. One is the BeagleBone Black and the other is Raspberry Pi. So let's understand what are the capabilities of these two boards and then choose the one that is suitable for the IoT platform. The first, let's look at the BeagleBone Black. Its specifications are it hosts the processor Citara AM3358BZCZ100, and it supports up to 1 GHz and 2000 MIPS. The graphic engine is SGX 530 3D20M polygons, and the RAM it has is 12 MB, DDR3L, and the onboard flash it has 4 gigabits, and also it has 8-bit eMMC. So the debug support is optional, 20-pin JTAG, so it provides the JTAG support also. The power source is NAS 5V DC, or it can be powered with an USB or DC jack. And the form factor, it's okay, both are similar form factors. And the indicators are it provides 1 power and 2 Ethernet for user controllable LEDs. So this is also important to see. Let's say if you want to do a GPIO or any toggling LEDs, so for user controllable LEDs also it provides. That's a good thing for embedded programmer. And it also provides the high-speed USB 2.0 client port, high-speed USB 2.0 host port, and there are some serial ports like UART 0, access via 6-pin 3.3 TTL hardware. The header is populated, okay, it's already available. And the Ethernet it has support for Ethernet also, and it supports STMMC connector. And the user input is like it provides 3 buttons, one for reset, one for boot button, and one for power button. The video output is also available, and the audio via HDMI interface. Both audio and video outputs are available via HDMI. And the expansion connector, so if you see this is expansion connector, so I think it's 96 pin or 94. So it is kind of pretty much extensive connections it gives. So if you see, it gives 5 volts and 3.3 volts in some pins, and then VDD ADC 1.8 volts. This is going to be a reference voltage for any ADCs, and 3.3 volts IO on all signals. And it also gives MCASP0, SPI1, I2C, GPIO 69 max. So that means up to 69 GPIOs should be able to access with this expansion connector. And it can support LCD, GPMC, MMC1, MMC2, 7 7 analog pins, the 4 timers, 4 serial port, CAN 0, and things like that. So it has a very good support for peripherals. And the weight, it's okay, 1.4 ounce. The power is, I think it can be powered with 5 volts. Well, this is about BeagleBone Black. So when we look at Raspberry Pi 4 features, it is the quad-core 64-bit ARM Cortex A72 running at 1.5 GHz. So if you see, it's much more powerful with respect to the frequency that it is able to run. And then 124 gigabyte. It provides up to 4 gigabytes of RAM, and it has H.265. It's a hardware decoder. It's for the video, and I think it's for both for 4K and 180. It supports, and it has a good video core and supports for dual HDMI display output. So this is the hardware feature, and the interface is, it also interface with the Wi-Fi, the wireless LAN, and it supports the Bluetooth, and one SD card, 2 micro HDMI ports support, 2 USB ports, 2 USB 3 ports, 1 gigabit Ethernet port, you can see, and 1 Raspberry Pi camera port, and 1 Raspberry Pi display port, and 28 user GPIO supporting various interface options. So up to 6 UART, up to 6 I2C, up to 5 SPI, and SDIO interface, DIP, okay. So 1 DPI parallel RGB display, 1 PCM, so up to 2x PWM channels, up to 3x GPC LK output. So if you see, it's more catered to video and audio processing and things like that. Though it supports the LAN and Bluetooth, and there are a lot of options for USB here, but I see it gives only the 28 pin header for us to expand or to use for external connections. So that is something which I feel it's limiting for us, because an IoT platform, we should be able to connect more sensors and actuators to the board. Well, after we saw the differences or the capabilities of both the boards, so I prefer to go with the BeagleBone Black revision C, because it offers a lot of connections, like 3 I2C bus, provides CAN bus, SPI, 4 timers, 5 serial ports, 65 GPIO pins, 8 PWM outputs, and 7 analog inputs. This is going to be very useful for interfacing any sensor or actuator. So that's something which we need to keep in mind when we are selecting a board for our IoT main board. Well, now that we have chosen the BeagleBone Black, and we know that it's powered by AM3358 processor. So let's go and see the documentation or technical documentation, so that we understand more about this processor. So this, as you know, this processor is from Texas Instruments. It's TI, and it is active. That means when we order, we should be able to get the processors. Let's say in case if you want to build our own product out of this. Okay, so that's the idea here. And we have the data sheet, the PDF or HTML format. So I will open the data sheet, and then the more important, or also I would say the very extensive documentation it provides, the user guide, also called as the TRM, the Technical Reference Manual. So what I know is it's going to be a very big document, and also we will have a lot of documentation with respect to hardware design and the software development. So some things like erratas, the user guide, as I said before, and the application notes, high-speed layout design, the interface layout, I think it's for the PCB design, and the design guides. There are a lot of application notes, and the white paper, time-sensitive network for industrial automation. You see, this more towards the automation or the IoT aspect, and the more literature from start to finish, a product development roadmap for Sitara processor. So it offers a bit of extensive documentation, so which is going to be useful for us in the future. So when we develop our own applications or drivers or anything like that. So let's see the data sheet, for example. If you see, let's get through the device overview. So I'll not spend more time here because this is not the scope of this video. Or so here we want to understand its capabilities, and then and to understand a little bit more about the processor. If you see the technical reference manual, it is 5,000 on odd pages. So it's a very good documentation. Of course, not everything is required for us to read, but at least whenever we require, we have to consult this document and then get an idea of how things work so that we program it effectively. So that's the idea. So it also gives a lot of information on how the product or the processor works at different levels. So with this, we will have a lot of information about the processor. So let's go through the device overview. As I said, it is capable of running up to 1 gigahertz, and then the architecture is Cortex A8. This is going to be the architecture. So this information is very useful when we are building U-boot and the Linux kernel for this board or for this processor. And it is also the Neon SAMD coprocessor. This information is also needed when we're building the Linux kernel or the U-boot or the tool chain, for example. Okay, so and then it has 32 KB of L1 instruction and data cache, instruction cache, and then 32 KB of data cache. Okay, all these are okay. And it has on-chip memory, 64 KB of general purpose on-chip memory is also available within the processor. It's an SoC, system on chip. So it has external memory interfaces, like it will support different memory interface like MDDR, DDR2, DDR3, DDR and things like that. Okay, so and the other things important for us with respect to is networking also. So it has supports for Ethernet IP, and few more things is enhanced GPIO module provider, provides shift input output support and parallel latch and external signal. This is something which we're going to use when we are working for, or when we develop device drivers for GPIO. And it has things like the RTC, which we would also use, and the peripherals is up to 2 USB. It supports 2.0 high speed as we saw before, and it supports 2 industrial gigabit Ethernet max, and it supports 10, 100 and 1 Gbps also. It has integrated switch, Ethernet switch, and each MCA supports, each MAC supports MII, RMII, or RGMII, and MDIO interfaces. So these are some of the interfaces for the Ethernet switch. So up to 2 CAN controller array network. This is a CAN protocol. So in future we will also look at the CAN driver and things like that. So we would use CAN for controlling or to have a network within or different. Of course, the use case differs, but in case we want to have 2 boards, for example 2 main boards to interact, we can use CAN protocol. That's also fine. So anyway, all these networking decisions we would do in the future, but we know that it supports Ethernet, and it has a USB in the CAN, and also it has the UARTs up to 6 UART and up to 2 master and slave SPI, and it has 3 MMC, ST and STIO ports. I think the BeagleBone has the provision for the SD card, the micro SD card. There are up to 3 I2C master and slave interfaces. So all this, of course, there are plenty of information that it is there, but one thing what we need to understand here is not everything or not all the peripherals are available for us. So what the controller or the processor does is we have something called the multiplexing, the port multiplexing. So with that, what we have is, say for example, one particular port would have support for two or three different operations. So one particular port, one port pin can support UART RX, and the same can be multiplexed with the MISO of SPI, and it could be an analog channel. So likewise, we will have a particular pin or a port pin will have multiple operations that it can do. So that will be selected based on the certain registers that we will see in the future. So as I see, there are a lot of learnings we will have when we start working on this project, not just on the Linux level but also on the embedded programming as well. Okay, so now we have seen a little bit about the AM3359 processor, and we chose the BeagleBone Black. So with that, the IoT architecture diagram with the BeagleBone Black sitting in the center of the architecture looks like this, where the master sensor and controller is BeagleBone Black revision C, and it's capable of interfacing with the sensors and actuators, plus we will have the networking ability in the future, where we will interface Wi-Fi or a Zigbee, any such network to this board, and then we will enhance this capability to work with the embedded sensor network. With this, we choose BeagleBone Black revision C as our master board, where we install embedded Linux and start developing IoT platform. Thanks for watching.
If this video helped you in learning, please like the video and subscribe to the channel. Also, share with anyone who is interested to learn more about embedded Linux and Internet of Things. Leave a comment below for any feedback or discussion.